Welcome to our virtual flight through the Rustringen cavern storage. During the flight, you can look around in all directions, but please stay seated. If you need any help or feel uncomfortable, you can remove the headset whenever you like. First, let's take a bird's-eye view of northern Germany. You might be able to spot the North Sea coast or one or two cities. A special feature of northern Germany's geology is its vast reserves of salt rock, which were deposited in the Zechstein Sea 250 million years ago. The Zechstein Sea stretched from today's England to Poland. Countless salt domes formed from the thick salt layer. Most of them are several kilometers in diameter and contain many thousands of cubic meters of rock salt. In fact, northern Germany sits on top of around 90,000 cubic kilometers of salt. That's more than 4 times the volume of the ice in the Arctic Sea in winter. Below ground, southwest of Wilhelmshaven, a large number of caverns have been created for the storage of crude oil. First, let's take a look at the surface above ground. The 38 caverns in Rustringen add up to a total cavity volume of 13 million cubic meters. Cavern heads are visible on the cavern pads. This is where the wells are connected to the pipelines on the surface. Now let's see where the caverns are located underground. Look down and you can see the wells and the many caverns that have been created in the salt rock. The well leads to the caverns about 1 kilometer further down. Underneath you, you can see the Rustringen salt dome. It is round in map view, about 5 kilometers in diameter. The cavern field is in the center of the salt dome, and the caverns are encased in several hundred meters of salt rock. Now we're inside the salt dome. Imagine you're standing in the middle of the salt rock and the caverns are all around you. A typical cavern is 200 to 400 meters tall and has a diameter of up to 60 meters. The sheer vastness of the caverns becomes clear when you compare them with other large structures, such as the Hamburger Michel, which stands 130 meters tall. The energy transition from fossil to renewable energy gives us new challenges to store large amounts of energy. One way to store the energy is to produce hydrogen and store it in salt caverns like is already done for oil and natural gas. For this, existing caverns can be repurposed, enlarged, or new caverns can be developed. The highlighted caverns you can see now are examples of such repurposed and enlarged caverns that would store hydrogen in the future. Let's look at a cavern from the inside. Now you're inside an oil cavern at a depth of over 1 kilometer. The cavern has a volume of 300,000 square meters. Above ground, you would need more than 3 large oil tanks for the same quantity. We're surrounded by several hundred meters of salt rock, which is so tight that no oil can leak out of the cavern. Their salt in the diapir is not completely homogeneous. In fact, there are different salt layers consisting of more or less pure salt. These differences could influence the leaching process of the caverns. Behind the caverns, you can see the salt layers in different colors on a vertical section. These details have to be interpreted based on a large number of geological data, but are essential to plan and build the caverns at the optimal location. The large surface around you is the boundary between 2 salt layers. As you can see, the salt layers have been strongly folded during the development of the salt diapir. Our flight underground has come to an end. We hope you got an impression of the fascinating world beneath your feet. Please remove your headset now. We'll be happy to assist you. Goodbye and have a great day.